Welcome to our second video of solving problems that involve the use of multiple skills. Sketching the problem plus placing the given numbers on the drawing plus using the sine and cosine rule to find missing angles and sides, and at last finding the bearing. So we're going to start with these steps. As I'm reading the questions, we are supposed to be sketching the drawing. An aircraft flies 500 kilometers on a bearing of 100 degrees. When I see a bearing question, start always with drawing the coordinate planes. The coordinate plane is the x-axis and vertical on it the y-axis. When they say bearing of 100, the bearing is measured from the north and clockwise. So you're going to draw an angle of 100 degrees using the protractor, or if you're good at drawing or sketching proportionally, then that's what you should do. So this is 90, so my 100 is going to be somewhere here, or you can measure it. So this is my 100, so I know that the length of the side 500, where the direction of it, where I'm going to draw it exactly, which is going to be this way. So this is my 500 distance and the direction of it. Now, once you draw the first part, and if the question carries on, then you must draw once again, at each ending point, you must draw once again the coordinate plane as following. So, the new bearing is 160 degrees. Again, the bearing is from this ending point here, so from the north, clockwise. And I know this is 90, this is 90, so all this is 180. And what I really want is the 160, so it's going to be somewhere here, or you can just measure it. So this is my 160. I know the direction of the line that's going to be 600 kilometers long. Now, this ending point and this is my starting point. I'm going to connect between them. And voila, that's the triangle that I'm looking for, where I can apply the sine and cosine rule on it to find missing sides and missing angles. Like I said, always draw the coordinate planes at the end of each ending point of my drawing. If I look here, I would like you to find any angle based on the given angles. The given angles is 100 and 160. So this angle is 80. Why? Because if we go back to angles of parallel lines, we're going to apply the rules of finding angles in parallel lines. So as you can see, north and north, they're parallel. And the 500 crosses both parallel lines. And as you can see here, I have this U shape, and the 180, we call them co-interior angles. And co-interior angles, they're not equal. They add up to 180 degrees. If we look here, there is one more co-interior angles. Like I said, north, north, and the 600 is passing through both parallel lines. So the 160, this one is going to be 20 because both they add up to 180 degrees. Now, I have two known sides, but none of the angles are known in my triangle. So if I go to this angle here, it's very hard to find it because I don't know this angle. I know that this is 90, this is 90, this is 90, but since this angle is missing, then I can't find this angle. Same case here, applies here. But if I go here, this is 160 and this small angle here is 80. So what is the angle between the two sides of this triangle? They are angle at a point, the 80 and the 160, and the unknown angle between the two sides of the triangle are angles at a point, and angles at a point add up to 360. So to know this angle, I must add the 80 and the 160 and subtract the result from 360. And that's how I find this angle as 120. Now, name each corner in this triangle as A, B, and C. Each angle carries the big alphabet, and the side that is opposite to the angle carries the small alphabet as following. Angle ABC, which we're going to call it angle capital B, is actually equal to 120. The opposite side to angle B is the side that is named AC or small b. The opposite side to angle capital C is actually the 500 kilometer. So that's why the 500 kilometer is equal to C small. The opposite side to capital angle A is the 600. So that's why the 600 is equal to small a. Now that we identified everything on our diagram, we can use the sine and cosine rule to find unknown angles and unknown sides. Use the cosine rule to find the length of AC, which is requested here, the distance between the ending point and the starting point. A and C, this is my starting, this is my finishing point. So, B is my unknown, and B is named as well as side AC. So, side AC squared, the other two sides are AB and BC. So, BC squared plus AB squared minus inside the brackets 2 times BC times AB times the cosine of the angle between the two known sides. Let's write it in an easier way. Side B small to the power of 2 is equal. What are the other two sides? A and C. A squared plus C squared minus inside the bracket 2 times A times C times cosine the angle between the two known sides. Let's substitute in this formula. A is equal to 600 and C is equal to 500. That's why it's going to be B squared is equal to 600 squared plus 500 squared minus inside brackets 2 times 600 times 500 times cosine the angle between the two known sides, which is cosine of 120. Now we are trying to find the 1b, so that's why we're going to square root each side. So it's the 1b is equal to square root of 600 to the power of 2 plus 500 to the power of 2 minus in brackets 2 times 600 times 500 times cosine 120. Now this is ready to be inserted in the calculator, but we're going to leave our answer as b is equal to square root of 9/10,000, and the measurement unit is kilometer, because all sides are given to us in kilometer. Now we're going to use the sine rule to find unknown angle. Can you correct this one here for me? We're going to find angle BAC, which is capital A. In other words, capital A. And we're going to use the sine rule as following. The side that is opposite to angle A is actually the 600. And the side that is opposite to angle B is the unknown side, which is B small. So let's substitute in this formula. A, it will be 600 over sine A, which is my unknown, is equal to square root of 9/10,000 over sine 120. If we cross multiply, we're going to end up with sine A is equal to 600 times sine 120, all divided by square root of 9/10,000. But this is the value of sine A. And if I'm trying to find the angle A, then I need to apply opposite operation. Opposite to sine is sine inverse. So we're going to sine inverse each side. So the 1A or angle A is equal to sine inverse of 600 times sine 120 over square root of 9/10,000. If we insert this in the calculator, we're going to end up with angle A equals to 33. Why 33? Because we always round our answer to three significant figures. So this is my first figure, the 3, the first 3 on your left, and the second 3 is my second figure, 0 is my third. Stop at the third one, look to its right. 0 is less than 5, so it's not going to bring my 0 up. So that's why angle A capital or angle BAC is equal to 33. Now that I'm finding the bearing of the finishing point from the starting point, this is my starting point, like I said, and the bearing is measured from the north, and you go clockwise. Shall I stop at the line, at line AB? No, because they said the bearing of the finishing point. So I must carry on until I hit the line that connects the starting with the finishing point. What are the angles here from the north to line AC? It's 133, and if we add them, they're gonna add up to 133. So the bearing of the finishing point from the starting point is 133. Let's try to apply the exact same steps on this question, which I left for you yesterday at the end of the video. And like I said, start always by drawing a sketch of the problem as you're reading the problem. A rocket flies 10 kilometers vertically. Always start by drawing the coordinate plane. So if it's going vertically, so we are starting from the original point and we're going up north. So this is my 10 kilometer. Then 20 kilometer at angle of 15. So my bearing is 15. So this is my 15 degrees. As you can see, it's measured from the north. And like I said, let's go back a little bit. Like I said, at the ending point, which is here, we draw another coordinate planes. And we measure the 15 degrees and then I draw the line that is 20 kilometers long. The trip did not finish yet. 60 kilometers at angle 26. So at this new ending point, I'm going to draw again another coordinate plane. And from the north, I will measure 26 degrees, so I know where the 60 kilometer line is going to be drawn. This is the end of my trip here. What they're asking us to do, calculate the vertical height of the rocket at the end of the third stage. So it's from this point down to the starting point. Now, like I said, you should always look for triangles. So if we finish, as you can see here, if we finish the lines here, can you see this right angle triangle? Perfect. If you can see this one, now I have one triangle. So what I really need to is, based on the given angles, to find the unknown angles. So these angles, this angle here and this angle here, they add up to 90 degrees. So if I name this as A capital, because we always give the capital letter to the angle, so A capital is equal to 64 degrees. And this one definitely, because they said that this is vertical. This is the vertical height of the rocket. So it's going to make 90 degrees here. So I named this one as B. And at last, C is going to be 26. Angles in a triangle, they add up to 180 degrees. Right across, so this is angle A. The side that is right across to angle A is going to carry the A small. The 60 kilometer is the opposite side to angle B. So that's why the 60 kilometer is equal to B small. And like I explained before, this is A small because it is the opposite side to angle A. Perfect. So I have here known angles, and I have only one side that is known, and I need to find this vertical side. So I'm going to use the sine rule. I'm going to use the sine rule to find the vertical side. So A small over sine of A capital is equal to B over sine B capital. Let's substitute in this formula. So it's going to be A over sine 64 is equal to B is 60, 60 over sine 90 degrees. Let's cross multiply. So when we cross multiply, A times sine 90 is equal to 60 times sine 64. We're solving for A. So we're going to get rid of sine 90 by dividing all by sine 90. Accordingly, A is going to be equal to 60 times sine 64, all divided by sine 90. If you insert this in the calculator, you're going to end up with A is equal to 53.9 kilometers. And this is rounded to 3 significant figures. Now, let's find another triangle. If we complete this line here, can you see this triangle? It's a right angle triangle. Let's find now the missing angle. If this is 15 and this one, it's going to be 90 minus 15, and I named it as x. So x is equal to 75 degrees. This is 90. As you can see, I named it as y. And this last one is 15 because angles in a triangle, they add up to 180 degrees. So 75 plus 90 plus 15 is equal to 180 degrees. And we name this x, y, z. Now, this side here is known as 20 kilometer. And I am trying to find the vertical side because here I found this distance from here to here, and now we're going to find this distance from here to here, and this distance is already known. So to find this distance, I'm going to use once again, and I named it as x. Why did we name it as x small? Because this side is opposite to angle capital X. This side is going to be equal to y small because the 20 kilometer is the opposite side to angle 90. Let's apply the sine rule once again. So x small side of x over sine angle x capital is equal to side y over sine of y, sorry, can you correct this one? Sine y capital. Let's substitute here. So y, as we can see, is 90 degrees. So this is y capital, not b capital. X is my unknown. Sine of x capital is 75, so its sine of 75 is equal to side y is equal to 20 kilometers, so 20 over sine of or y capital is actually equal to 90, so it's sine of 90. Let's cross multiply. So it's x times sine of 90 is equal to 20 times sine of 75. We're getting rid of sine of 90 by dividing all by sine of 90. So x is equal to 20 times sine of 75 over sine of 90. If you insert this in the calculator, you're going to end up with A is equal to 19.3 kilometer, and this is correct to 3 significant figures. Now, if we want to calculate the vertical height, the total, so from here to here is 15.3, and to carry on from here to here, this is equal to 19.3, and we know that this one is 10. So if we, to find the vertical height, if we add the 3 vertical heights, we're going to end up with 83.2 kilometer, and this is again correct to 3 significant figures. Now you can apply the exact same steps that we used in the previous 2 questions to solve this one. And I will see you in another video sometime soon. Kindly like, share, and subscribe to my YouTube channel.